Hello friends, I am Professor Rajendra Koranne from my channel Teach Easy. This is the second video lecture of design of structure. In this video, we will start talking regarding steel structures. Here, we will see what are the advantages and disadvantages of steel as a construction material. In the last video, we saw that when principal material of construction for the structure is steel, it is known as steel structure. Now, from this video, we will talk about steel structure. Now, when the steel is used as a construction material, what are its advantages? That we will see now first. Okay, there are number of advantages. So, we will see first advantages and then we will see disadvantages. Now, the first advantage is high strength per unit mass. Means strength of steel in tension and compression are equal. It is highest in almost all the materials per unit mass. What is the meaning of high strength per unit mass? If you take a small angle section, as it is small, its weight will be less, but its strength is high. So, even if for the members having less masses, strength can be higher. This is useful in case of bridges where the spans are long. So, bending moments are more. So, strength required is more. At the same time, weight should also be as minimum as possible. So, this is the most important advantage of steel, that is high strength per unit mass. Number 2, being ductile, it gives visible signs of failure by large deflection. We know it is ductile in nature, due to which what happens even if the load is excessive, it will show large deflection which gives us an intimation of failure. Number 3, due to its ductile nature, its premature failure before maturity can be prevented by relieving the overstresses in certain members. Certain members are overstressed. When certain members are overstressed due to some actions of loads, there is a possibility of premature failure. This can be prevented due to the ductile nature of steel, because as it is ductile, some overstresses can be relieved, okay, due to redistribution of moments and all these things. So, you need not go in much details. The third one is due to its ductile nature, premature failure can be prevented by relieving overstressing in some certain members. Fourth one, it is more durable. We see durability, we already saw the excessive deflections without causing loss of strength, loss of stiffness is durability. So, steel has a very good durability. Number 5, it is tough. What do you mean by tough? It has got strength as well as ductility. Now, due to this strength and ductility, what happens? When steel structures are fabricated, okay, number of actions can be performed on it. Various actions can be performed on it. Hammering, bending, quenching, all other number of operations can be performed on it. Okay, drilling, punching. Okay, so when these operations are performed, there are no signs of visible damage on that particular steel member. So this is due to its property of toughness, that is, it has got strength as well as ductility. Okay, when you will hammer it, it will have to absorb some impact energy. So this is number 5. Number 6 is, as they are lighter, easy to handle and transport. Number 7, long life. If they are properly maintained, steel structures have long life. Number 8, properties of steel do not change with time. Steel is a factory product which is manufactured at better control. So its properties are reliable. At the same time, they do not change with time. Next advantage is additions and alterations in steel structures are easy. If you want to change some particular member, if you want to make some particular member strengthen, you can add it. Okay? So these additions and alterations, that is changes, are easy. Next one, it is speedy in erection, as it is light. So speed of construction is also more. Then next one, steel has the highest scrap value among all other materials. And the last advantage, it is reusable. Means if you dismantle any particular structure, some particular member can be used at any other place, that is reusability. If it cannot be used at all anywhere, it can be recycled. Okay? If you cannot reuse it, you can recycle it. So these are some of the advantages, 10, 12 advantages I have told you. I will once again repeat one by one. High strength per unit mass. Being ductile, it gives the signs of failure in advance. Third one, due to ductility, premature failure can be avoided. Fourth one, more durable. Fifth one, tough. Sixth one, easy to handle and transport. Seventh one, long life if it is maintained properly. Eighth one, properties of steel do not change with time. Ninth one, additions and alterations are easy. 10th one, speedy in erection, that is speedy in construction. 11th, highest scrap value. And 12th, reusable. If cannot be reused, it can be recycled. So these are number of advantages of steel as a construction material. Now let us go for the other side of the coin, that is, let us see the disadvantages of steel as a construction material. The first disadvantage is its high cost. Second one, it is susceptible to corrosion when it comes in contact with water and air. Due to that, what happens? Anti-corrosive painting is necessary, which increases the cost. Third one, it loses the strength rapidly during fire. If there is a fire, its strength reduces rapidly. Okay. Fourth one, for longer and slender members, they fail by buckling very easily. That means full strength of steel cannot be utilized for longer and slender compression members. And the fifth one is, it requires skilled and trained labor for fabrication as well as erection. So these are the disadvantages. I will repeat once again. High cost. Second, susceptible to corrosion. So anti-corrosive treatment increases the cost. Third one, it loses the strength rapidly during the fire. Fourth one, long and slender compression members fail by buckling very easily, due to which full strength of steel cannot be utilized. And fifth one, it requires skilled and trained labor for fabrication and erection. Do you understand? So these are advantages and disadvantages of steel as a construction material. Okay. Now, after discussing about the advantages and disadvantages of the steel as a construction material, let us see what are the civil engineering works where steel structures are extensively used. The steel structures are used extensively for following civil engineering works, one by one. 1. High-rise building skeletons. Skeletons of high-rise building. 90 stories, 50 stories, 60 stories, like that. So skeleton of high-rise building is of steel structures. Second one, industrial buildings. Third one, transmission towers. Now you know transmission towers are for high tension power lines, high tension transmission lines. Towers are for mobile transmission lines, for radio transmission, for radar and other communication system. So everywhere towers are used, and those towers are made up of steel structure. Fourth one, bridges. Just now I have told you that as the strength of steel is high per unit mass, it is very suitable for bridges. Now in bridges, number of bridges are there. There can be ROB. What is ROB? Railway over bridge. There can be a highway bridge. There can be FOB on the platforms of railway station. FOB means foot over bridge, which we use for shifting from one platform to another. That is FOB. Then for overhead tanks. If you see the tanks on railway station, they are steel tanks. Overhead tanks elevated from ground. Then chimney stacks, chimneys, stacks. They are hollow inside. They are used for liberation of gases. Okay. Then silos and bunkers. What are silos? Silos are structures which are used in industries to store huge materials, which is passed batch by batch for processing. Okay, silos and bunkers. Then roof trusses. What are roof trusses? If you want to provide the roof for a big auditorium or a big cinema hall or a big community hall, you cannot provide the slab over there. So you have to use steel structure, and the roof is supported on the trusses, which are known as roof trusses. Then the last one is gantry or crane girders, which are used in industries for lifting and transporting heavy equipment and machinery from one place to another, is known as gantry girder or crane girder. So I will repeat once again: high-rise building skeletons, industrial buildings, transmission towers, bridges, overhead tanks, chimneys, silos and bunkers, roof trusses, and gantry and crane girders. So I have told you 9 important civil engineering works where steel structures are extensively used. Now in this video we are discussing regarding steel as a construction material. So let us go for a most important typical stress strain curve for mild steel. You have studied in your mechanics of structures stress strain curve for mild steel. Okay? You have to just proceed a slight deep. Now here the specimen is prepared and tested as per IS 1608. Gradual loads are applied from which stresses are calculated and corresponding strains are also calculated and they are plotted, plotting strain along x-axis and stress along y-axis. We get a graph which is known as a stress strain curve. Okay? So along x-axis I have plotted percentage strain, along y-axis I have plotted stress. Okay? So initially as load increases, strain and stress are proportional up to this point P. So this point P is proportional limit, which is very difficult to observe practically. Just to understand the concept I have shown this. Practically it is very rare it is visible, elastic limit or proportional limit. Then this is upper yield point. Y1 is upper yield point. As load increases, strain does not, that is, it is constant for a small period and it goes to lower value. This is lower yield point. Stress corresponding to Y1 is upper yield stress. Stress corresponding to Y2 is lower yield stress. Stress corresponding to P is proportional limit. Then, even if load is increased, strain increases without any considerable increase in stress. So this is idealized, which is seen as a horizontal line. When the load further increases, strain increases along with stress up to this point U, that is ultimate stress point. At this ultimate stress point, you know that neck formation takes place, and for further elongation or further strain, less load is required, so stress drops and finally it breaks at point B. So again I will tell you, P is proportional limit, stress corresponding to this is proportional limit, Y1 is upper yield point, stress corresponding to upper yield stress, and strain corresponding to this is 0.16%. The strain at which strain hardening commences is 10 times this epsilon y. Okay? So look here. Strain corresponding to y1 is 0.16%. Lower yield stress y2 is 0.22%. And up to 1.5%. So nearly 10 times epsilon y. Epsilon denotes the strain, that is yield strain. So it is nearly 10 times yield strain. At this strain hardening commences, that is starts. In higher structural language, it is known as strain at onset of strain hardening. Okay, so this is 1.5%. So you can see that this is 0.16 and this is 18. So this is 100 times, approximately 16, 18, 100 times epsilon y, it is ultimate stress. Okay, so I can write over here, strain hardening commences at 10 epsilon y and ultimate stress takes place at 100 times epsilon y. Do you understand this? And thereafter, okay, it fails. Now, here the strain is very large. From here you can see this portion is very large. So it gives excessive deflection, due to which this ultimate stress corresponding to U, that is ultimate stress, is not taken as a failure stress, but yield stress is taken as a failure stress. Okay, so this stress is taken as a failure stress. So this is the stress strain curve, typical stress strain curve for mild steel. See, look here, from here to here it is a straight line. So this is elastic zone, this is yield zone, or it is also known as plastic zone. This is strain hardening region or zone, and this is post ultimate stress. Do you understand? So this is the stress strain curve. Once again I will repeat, P is a proportional limit, Y1 is upper yield, Y2 is lower yield point, U is ultimate point, B is breaking point. Okay, so in this particular video we saw first the advantages of steel as a structural material, disadvantages of steel as a structural material, then various civil engineering works where steel structures are used, and last and very important, that is typical stress strain curve for mild steel. I think you have followed this. Thank you.